Hello everyone, welcome to an algebra video tutorial. We're learning about scientific notation and directly applying everything we've learned about exponents and exponent properties in this unit to actual science application. So scientific notation is a helpful way to take very large numbers, which we did in the last video, and we're taking very small numbers, which we're going to do in this video, and write them in an easier to use way or a different notation that is much easier to use mathematics with. So here we have the mass, and again, science has shown that mass of a red blood cell is approximately 0.00000, a bunch of zeros, 27 grams. A very small number, and we're going to convert it into scientific notation. All right, so let's talk about scientific notation. Just review it a little bit. So scientific notation. There's some things that have to happen. It's always in the form a, need some value a, times 10, because our number system is based off of place values that are times 10s of each other, to the nth power. Okay, so let's break down what that is. Remember, a is a value. A is between 1 and 10. And so if I look at my example here, my value for a, I look for the significant digit, so this 27 part right here, and I need to move the decimal to turn the significant digit part into a number between 1 and 10. So the decimal is right here to start off with. I'm going to move it up right behind the 2. And so my number, if I'm turning this into scientific notation, I'm going to start with 2.7. 2.7 is a number between 1 and 10, and it's a significant part of the number that I'm given here for the mass of a red blood cell. All right, check. We've got part 1 done. We've got our number between 1 and 10. The second part is we always have to have it multiplied by 10. Multiples of 10. So that's where the whole times 10 comes into play, because every digit in my number in our whole base 10 counting system is a multiple of 10. We have the tenths place, the hundredths place, the thousandths place. If I go bigger, I have the tens, hundreds, thousands the other way. So we're multiplying, we moved our decimal place, so we have to recognize, oh, every time we move our decimal, that's a place value, another multiple of 10. So there's my times 10. Check, got that. Scientific notation, the first number has to be between 1 and 10, and we always have to be multiplying by 10. All right, the third part deals with the n. What does that n mean? That's our exponent, and it tells us, well, how many 10s do we need to multiply by? Or how many 10s did we move by? So we count the decimals moved, number of decimals moved, from the number in standard notation to the rewriting it in scientific notation. So let's count here. So we moved it, we started right here. We moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. Now, when large numbers, we put a positive exponent because we took a large number, made it a smaller number between 1 and 10, but I had to recognize, well, to get back to the original number, we multiplied by a lot of tens. This is a very small number. If I compare 2.7 with this number, to get 2.7 to turn into this number is a lot of division by tens. I'm making it smaller. As I'm going to the right, I'm making it smaller by another power of 10. So in this case, I need to recognize, oh yeah, there's 13 times I did 10, but I made it smaller by 10. Every time we move the digit to the right, it's dividing by another power of 10. And remember when we did all that stuff with negative exponents, whenever I'm referring to repeated division, I need to use a negative exponent. So in this case, to show that I take 2.7, divide it by 10, 13 times, I need to put a negative 13. It's to the negative 13th power. So hopefully that makes sense. If you're dealing with a really small number and turning it into scientific notation, we tend to use negative exponents. If we're dealing with a very large number and putting it into scientific notation, we use positive exponents. But there we go. We have now converted the mass of a red blood cell into scientific notation. It's 2.7 times 10 to the 13 grams. All right, hopefully that is helpful for you in converting numbers in either your science or chemistry class or in your math class.